Professor V. Muralidhar is serving as Head, Department of Mathematics, Mohammed Satak College of Arts and Science, Chennai. He has 23 years of teaching experience. He has attended 3 international and 5 national conferences. He was a resource person at the Mohammed Satak Teachers Training College in Chennai in 2012, where he spoke on History of Mathematical Genius Ramanujan. He was elected Academic Counselor, University of Madras during 2003-06. He has attended the Orientation and Refresher courses at the Academic Staff College, University of Madras. He specializes in stochastic modeling and has rich experience in discrete mathematics, operations research, statistical methods, and numerical analysis.
Welcome to UGC lecture series. In the last session, we have seen important time series analysis, that is method of least squares. And in the method of least square, we have fitted straight line method, and another one is parabolic or nonlinear trend method. And we have seen simple problems based on them, merits and demerits of those trend lines. Today in this session, we will start with exponential trend methods. Another important method called exponential trend and ratio to trend method and exponential trend method. So in this, the equation of exponential trend, it is of the form y is equal to a into b power x. Here the objective is to find the value for a and b. So to determine that, we use logarithmic method. So you putting the equation in the logarithmic form, that is you take log on both sides. So we get log y is equal to log of product, which will be sum of the logarithms. So we get a log of a plus log of b power x. If we use exponential of rule of logarithm, we get x into log of b. Now when plotted on a semi-logarithmic graph, the curve gives a straight line. However, an arithmetic chart, the curve gives a nonlinear trend. To obtain the values of the constants a and b, the two normal equations are to be solved for the above equation. Since the above equation represents a straight line, we have the normal equations with respect to straight line form. So we get sigma log y is equal to n into log a plus log b into sigma capital X. Sigma of x into log y equal to log a into sigma x plus log b into sigma x square. Now how to fit the exponential trend? So we have the following methods which are given in the form of different steps. So step 1, find the time deviation of each year from the middle year and denote these values, the deviations, by capital X. Second, in the step 2, square these deviations and obtain sigma x square. Then obtain the logarithms of the variable y. So for each y value, you have to write logarithm. Then multiply log y by the corresponding time deviation and obtain x into log y column. Now in the step y, you divide sigma log y by capital N, which will give you the value of log of a. And similarly in the step 6, the rate of growth will be sigma x log y divided by sigma x square. You put the value of log a before the middle year and add or subtract the slope of the line, that is the value of log b, to get the trend ordinates in the logarithms, taking anti-log of these logs to arrive at the actual trend values. Let us see by a simple problem. Consider the following problem, which gives the sales of a company for the year 2003 to 2009, and you are given year and the corresponding sales in millions. Year on the 2003, 2004, 2005, etc. 2009. Correspondingly, the sales are 32, 47, 65, etc. up to 275. The objective is to find the trend values by using the equation y is equal to ab power x, that is exponential trend, and estimate the value for that for the year 2012. Now let us move to how to compute this by the following calculations. So here we got different columns. First column indicates year from 2003 to 2011 given in the problem, and the n denotes number of years, which is 7. Then sales only we represent by y. For each year is given 32, 47, 65, etc. up to 275. Next, for x value you are taking a middle year and subtract 2006, subtract from all the other years. You get a 0 in the middle, above and below you get positive and negative values. And if you take summation, sigma x will be 0. Then you take a log for each of these values. When I take a log of 32, it is going to be 1.5051. Log of 47, 1.6721, etc. Log of 275, you get 2.4393. Then you compute x square. Square each of these x values. Minus 3 square, minus 2 square up to 3 square. So we get 9, 4, 1, etc. 9. And the summation of x square will be 28. Summation of log y will be 13.7926. Then x into log y. Multiply each value of x with the corresponding log y. Minus 3 into 1.5051, minus 4.5153, minus 2 into 1.6721, minus 3.3442. So like that, the last one 3 into corresponding 2.4393. So you get 7.3179. If you add all these values, sigma x log y will be 4.1655. Now let us substitute in the logarithmic normal equations. So log a is equal to sigma log y by capital N. So we get 13.7926 by 7. So we get 1.9704. Similarly, log b will be sigma x into log y by sigma x square. And from the above table, sigma x log y is 4.1665. Sigma x square 28. So if you divide, you get 0.149. So log y is 1.9704 plus 0.149 into x. So this will give you the corresponding logarithmic trend curve. And for 2012, the corresponding x value will be 6. Hence, your log y is, you substitute in this 1.9704 plus 0.149 into 6, that is 2.8644. Now, if you take anti-log for this, that is going to give you corresponding y value. Hence, y is equal to anti-log of 2.8644, that is 73318. Since your characteristic is 2, we have got 2 plus 1. So after 3 decimal we put, after 3 integers we put decimal point. So we get y is equal to 731.8. That means the estimated sales for the year 2012 is 731.8 millions. Second example. The sales of a company for the last 8 years are given below. So he has given the year from 2004 to 2011, and the corresponding sales he has given in terms of thousands, 52, 45, 98, you go up to 220. Then you estimate the sales for the figure for 2012 using the exponential function y is equal to ab power x. Now let us say calculation. So in this calculation we take x year to be 2004 to 2011. So the number of years is 8. Similarly, y value 52, 45, you got up to 220. Sigma y 977. And deviations from 2007. You take origin as 2007, and above you are going to get negative value, and below you get positive value. So sigma x will be 4. Then log y. Find log for each of the given values of a y. You get 1.7160, 1.635372, etc. 2.3424. If you add, sigma log y is 16.2182. Similarly, x square. Square each value of x. So 9, 4, 1, 0, etc. 16. So sigma x square is 44. Then sigma x log y. Multiply each value of x with the corresponding log y. So minus 3 into 1.7160 minus 5.1480. And the last one, you got 4 into 2.3424, you get 9.3696. If you add, sigma x log y will be 12.2288. Now the logarithmic form of the equation is given by log y is equal to log a plus x into log b. Then the values of constants are obtained by following two normal equations given in terms of log, and sigma log y is 16.2182 and n is going to be 8, log a plus 4 log b. Similarly, sigma x log y 12.2288, 4 log a plus 44 log b, that is the second equation, and you take the first one minus 2 times second equation, it gives log b is equal to 8.2394 divided by 84, that is 0.0981. Now you putting the value of log b in 1, we get 16.2182 equal to 8 log a plus 4 into 0.0981. So from this we get log a is equal to 1.978. Hence we have log y is equal to 1.978 plus 0.0981x. So for 2012 x is 5. So y is equal to anti-log of 2.4685. So y value will be 294. Hence the estimated sales value is 294.1 thousands. Below are given the figures of production, each lakh tons of a sugar factory, and he has given year and production, year on the 2006 and up to 2011. So we have 6 years. Production 77 lakhs, 88 lakhs, 95 lakhs, etc. 127 lakhs. You fit a trend line y is equal to AB power x to the above data and tabulate the trend values. So trend line will be log y is equal to 2.0075 plus 0.222x, which is going to be a straight line. And trend values, you substitute the above trend values for your corresponding each year and substitute in this, we get trend value to be 78.7, 87.22, etc. 131.5. Second one, below are the given figures of production company, which has given in terms of lakhs of tons in a sugar factory, and he has given the year to be 2010 to 2015, and the corresponding product sales 7586, you got up to 117125. Fit a trend line y is equal to AB power x to the above data and tabulate the trend values. So the answer is log y is equal to 2.0045 plus 0.0219 into x. Now let us move to another important topic, that is measurement of seasonal variations. See, there are different methods of seasonal variations. First one is simple average method, second one is ratio to trend method, and ratio to moving average method, finally link relative method. When you take simple average method, the simple average method of measuring the seasonal variation is suitable when the trend and cyclics are not present, if any, have negligible effect on the time series. To calculate seasonal indices, first find out the average of each period, which can be season also, and then the average of averages, that is grand average. Then seasonal index for any period is defined as, in this case, of a multiplicative model. Hence your average of a season divided by grand average. For example, you take x1 bar, x2 bar, etc. xn bar. They denote the seasonal averages based on the periodic data for all the years, and x bar denote the grand average. Then seasonal indices for multiplicative model are x1 bar by x into 100, x2 bar by x into 100, etc. xn bar by x into 100. Also for the additive model, the same seasonal indices, they are given by x1 minus x1 bar into x2 minus x2 bar x bar, etc. xn bar minus x. This is for the additive model. And what are the merits and demerits of this method? Merits are, it is the easiest method to compute the seasonal indices. It gives good results of trend and cyclic variation have negligible for no effect on the time series, which is rarely used. Hence this method is seldom used. Demerits, it is not appropriate as it does not remove the cyclic and irregular variations. If seasonal indices are so obtained or to be adjusted for trend, then this method becomes quite cumbrous. Let us solve it by following example. Find the seasonal index for the following data. He has given the year 2011 to 2014, and for each quarter he has given the corresponding productions, and 3.7, 3.7, etc., 3.3, 4.1, etc., 4.4. Finally 3.5, 2.6, 2.1 and 40. And in this, what are the seasonal indices for various quarters? How to compute calculations for seasonal indices? The average of averages is 3675 divided by plus 4.125, and you go on adding up to 3.55. Actually, the average values are given in the data. You add all the values and substitute in this, you get 3.725. Similarly, for each quarter you have to compute. So it is going to be QA by GA. GA is going to be general value, general summation. QA is going to be for the particular summation. Since in the previous problem we got in the particular solution, it is treated as your corresponding index. Now we compute seasonal index for each quarter. For the first quarter, your seasonal index is your QA by GA. QA is going to be quarter average and GA is going to be general average. So 3.615 by 3.725, which is 96.66. For second quarter, 4.12573.725. So we get value to be 110.74. For third quarter and fourth quarter, both have same trend value. So we get trend curve to be 3.55 by 3.725 into 100. So we get 96.30. And you take the table of values where you are given year. For each quarters you are given the values. You have to compute the corresponding seasonal index for each quarter. First you take the total. So for the first quarter it is going to be 14.7, for second quarter 16.5, for third quarter 14.2, fourth quarter 14.2, and the average is going to be 96.66. Second one 110.74, third one 95.30, fourth one 95.30. Now you take simple exercise problem. Calculate the seasonal index from the following data using simple average method. So you take year on first 2007 to 2011. For each quarter the values are given, and any general average will be 76.4. And the seasonal indices for quarters are 98.43, 92.15, then you got 106.9, 100.52. Now next we move to what is called ratio to trend method. So in this method we also call it as percentage to trend method. This method provides seasonal indices free from the trend, as it assumes that seasonal variations for a given period is a constant fraction of trends. Various steps of computations are given as follows. Step 1. Estimate the trend values for each period, which can be either quarter or month, by establishing a trend line, or it can be a parabola also, by the method of least squares. In the second step, you divide each originally given seasonal, which is quarter or month value, by the corresponding trend values and multiply it by 100 to convert it into percentage. The indices so obtained are free from the trend. In the step 3, to obtain seasonal indices free from cyclic or irregular variations, find the median or mean, you can find any average, of ratio to trend values for each season for any number of years. The median is preferred over the mean if there are some extreme values. This median or mean values represents seasonal indices. Mean removes the random effects better than the median. Hence, one should choose median or mean after a careful examination of the data. In the step 4, if the seasons are quarters, then the sum of the seasonal indices in case of a multiplicative model, it should be 400, and if it is months, it should be 1200. But often the sum is not exactly what it should be. Hence, the seasonal indices are adjusted by multiplying each of them by 100 divided by sum of the seasonal indices, or 1200 by sum of the seasonal indices, as the case may be. And what are the merits and demerits of this method? Some of the merits are, this method is based on sound and logical footings. Second one, it utilizes the complete information. Third one, if periods are of short duration, it gives very good results. Fourth one, it is easy to compute and understand. And what are the demerits? If there are pronounced cyclic swings in the time series data, a linear or curvilinear trend does not give good trend values. In such a situation, ratio to moving average method performs better than ratio to trend method. Let us see some of the simple problems. Find the seasonal variations by the ratio trend method from the following data. So we are given the year from 2012 to 2016, and for each quarter he has given the corresponding values. So for 2012 you got 30, 40, 36, 34. For 2013, 34, 52, 50, 44. And finally for 2016, 80, 92, 86, 82. Now let us see how to compute the seasonal indices. First we will determine the trend for yearly data and then convert it to quarterly data. So from the following table, he has given the year in the first column 2012 to 2016, and the number of years is 5, and yearly totals. So if you add all the first yearly totals, you get 140. That is, for 2012, 30 plus 40, 70, 70 plus 36, 106, 106 plus 34, 140. So we get 140 here. Similarly for 2013, it is 180. So you have to add 34, 52, 50, 44. So we get 180. For 2014 we get 200, and for 2016 we get 340. Then yearly average. So you take 140, you have to divide by the number of years, which is going to be 5. 140 by 4, you are going to get 36. Then 180 you divide by 4, you get 45. Then 200 you divide by 4, you get 50. Like that, 340 by 4, you get 85. So this will give you the yearly average for each corresponding years, and total yearly average is 280. Then you take the deviations from the mid year. So in this problem we take middle year to be 2014. So you subtract the values from all the other given values, you get -2, -1, 0, 1 and 2. Then multiply each x value with the corresponding y, you get xy column. So -2 into 36, -72, -1 into 45, -45, etc. 170 you get by multiplying your 2 with 85, and total sigma xy will be 120. Then x square, square each value of this x column, you get 4, 1, 0, 1, 4. So sigma x square will be 10. Then you get the corresponding trend value by substituting in the equation. Now to determine the trend value, you have to find the y is equal to a plus bx form, where a is given by sigma y by n, that is 285 by 5, which is 56. Then b with the sigma xy by sigma x square. Sigma xy we got to be 120, sigma x square is 10, so we got 120 by 10, that is 12. Then your trend line is going to be 56 plus 12 into x minus 2012. So the quarterly increment is going to be 12 divided by the number of quarters, that is 4, which is going to be 3. Now how to compute the quarterly trend values? For example, you consider 2012, then the trend value for the middle quarter, which is going to be the half of second quarter and half of the third quarter, which is going to be 32, and the quarterly increment we found to be 3. So the trend value for the second quarter will be 32 minus 3 by 2, which is going to be 30.5, and for third quarter it is going to be, you have to add this 3 by 2. So 32 plus 3 by 2, which is going to be 33.5, and the trend value for the first quarter is going to be 30.5 minus 3, which is going to be 27.5, and for the fourth quarter you have to add this 3, 33.5 plus 3. So we get 36.5. We thus get the quarterly trend values as shown below. So we calculated 2012, first quarter 27.5, second 30.5, etc., fourth 36.5. If you compute similarly for 2013, first quarter will be 39.5, second 42.5, third 45.5, fourth 48.5. And finally for 2016, first quarter 75.5, second quarter 78.5, third quarter 81.5, fourth quarter 84.5. And the given values are expressed as percentage of the corresponding trend values. So for the first quarter of 2012, you take the percentage to be 30 divided by 27.5 multiplied by 100. So we get 109.09. For second quarter, we get 40 divided by, so you should take this trend value. So 40 you divide by 30.5, which we got for second quarter for 2012. You multiply by 100. So that is going to give you 131.15, etc. So all these trend values are given here. So quarterly given as percentage of trend values. For 2012, first quarter 1009.09, second quarter 131.15, which we have seen just now, third quarter 107.46, fourth quarter 93.15. Similarly, for all other 2013, we get 88.08, etc., 90.72. Finally, for 2016, 105.96, 117.20, 105.52. Finally, for fourth quarter, 97.04. And you should take a total for each of these quarters. We get 463.84 for first quarter, etc. For the fourth quarter, 445.77. And you should take the average of this. You divide this one by 4, you get 92.77. And you divide by number of years is 5. You divide by 5, you get 92.77. For 591.47 by 5, you get 118.28. Finally, 445.77 by 5, you get 89.15. So your seasonal index adjusted is going to be 92.05, 117.36, etc., 88.46. Now, what are the merits and demerits of ratio trend methods? See, this method is more logical procedure for measuring the seasonal variations. It has a ratio to trend value for each month for each data which are available, and thus there is no loss of data as occurs in the case of moving averages. And it is very simple to understand and very simple to compute. And what are the demerits? See, in the demerits, if there are pronounced cyclic swings in the series, then the trend, whether it is a straight line or a curve, can never follow the actual data as closely as a 12-month moving average does. So when you take comparison, then it will not be too close to that one. In consequence, as a seasonal index computed by the ratio to moving average method, it may be less based on than the one calculated by ratio to trend method. In all these demerits and merits, we have seen how to use this ratio to trend method. And summary, see, in this session we have learned about exponential trend method and simple average method, and we have seen some of the merits and demerits of these methods, and we also computed seasonal indices with some simple problems based on them. Now let us see some of the simple questions which are to be answered by you. Find the seasonal variations by the ratio trend method from the following data. So in this data he has given the year from 2005 to 2009. So the number of years will be 5, and for each of these year, for all the 4 quarters, you are given the values. That is, for 2005 we got 36, 42, third quarter 36, fourth quarter 34. For 2006, 34 for the first quarter, second quarter 52, and the last fourth quarter 44. Similarly, for 2009 we have first quarter 70, second quarter you got 92, third quarter you got 76, and fourth quarter you got 72. Now for the second also you can determine the seasonal variations by using the ratio trend method. So in this case you are given the year from 2012 to 2016 and values are given for each of the 4 quarters. So you compute the seasonal variations like in the preceding problem. And in this method we also call this method as ratio to trend method. Thank you.